This is the third and final video for section 2.3 of Pre-Calc 11. So if you're following along in sort of the intended order of things, at this point you should have seen the first two videos for this section, as well as the grade 10 trig review and the first video for section 2.2. So if you've seen all that, you're in the right spot. If not, I would go back and watch one of those videos. So this video is all about two triangles, which we're going to call the special triangles. So we'll get to those in a bit. The key concept that sort of underpins this is that there are some specific angles and side lengths that do tend to come up quite a bit when we're doing trig, and especially when we're trying to do trig with exact values. We dabbled our toes into this a little bit in the first video for section 2.2, where we did some exact value trig with points, with coordinates. So we did Pythagorean theorem, we got R values and stuff like that. This video is a little different, so it is still going to involve some exact value trig, but there is no coordinates. It's just a slightly different perspective on things. So I'm just going to go straight into it. So we're going to have two triangles that are hopefully going to look a little better than that last one I tried to draw. And these triangles are going to have some common repeated values that we're going to see a lot. So the first has two 45-degree angles and a right angle. And then the side lengths of this triangle are, well, 1 and 1 on the legs, and then the hypotenuse is going to be root 2. Our second triangle is going to look something like this. And it is going to have angles of 30. So this will be 30 down here, 60, and 90, so a right angle. And so our side lengths on this one are going to be 1 again, then root 3 down here, and 2 on the hypotenuse. So collectively, these two triangles are known as the special triangles. And so you are going to have to memorize these. These are going to be the kind of thing that you're going to be using constantly, so you really need to know them just kind of like automatically. You're going to be drawing them a lot, so definitely get the sense of them now. A quick tip to help you put things down properly. So there are a lot of numbers going on here. The key things to remember, the angles 45, 30, and 60 should be hopefully pretty easy to remember. So 45 and 45, we've got two of those together. And then in our other one, this triangle is really just called the 30, 60, 90 triangle. So if you can remember that, you should be okay. So our important thing to remember, just as a fact of geometry, is that the bigger an angle is, the bigger its opposing side will be. Which makes sense if you think about it, right? If you put your hands together and you make an angle with them, if you open your hands wider to make the angle bigger, the distance across from them, the distance between your fingertips, will get bigger. So the bigger the angle, the bigger the opposing side. And if you can keep track of that, that should help you to remember where to put things on here. So in our triangle on the right especially, our smallest angle is 30, and our smallest side is 1. And so those go across from each other. Our biggest angle is 90, and our biggest side is 2. So those go across from each other. The other thing to keep track of is just where the roots go. So the root 2 triangle goes with the 1 and the 1 in the 45-45 triangle. The root 3 goes in the other triangle. And both of our hypotenuses have 2's in them, but one of them is a root and one of them is not. So it really does just take a little bit of work to kind of get those things internalized. So let's try putting this to work. A pretty typical sort of basic question would be something along the lines of determine the exact value of a trig ratio for a specific angle. So the exact value, let's say, of sine 30 degrees. So all we have to do really is we look at our corresponding triangle. So look at the connected special triangle. In this case, we want the triangle that has 30 degrees in it. And so I'm just going to sketch it out again. You're really going to want to kind of get into the habit of drawing these as often as you can. And I'm going to flip it on its side just to kind of mess with our heads a little bit. So our smallest angle is 30 degrees. Our other angle is 60. And so if we're labeling our sides, remember, across from the smallest angle, we get our smallest side. So the 1 has to go down here. Our 2 is our hypotenuse, and then our root 3 is the remaining side. So sine is just, well, SOHCAHTOA. Sine is opposite over hypotenuse. And so if we want to do sine of 30, our opposite from 30 is 1, and our hypotenuse is 2. So we get sine of 30 is 1 over 2. And if you plug that into a calculator, you would get sine of 30 equals 0.5. So hey, we got an exact value. Granted, this was a pretty boring one because it's just a decimal or a fraction. But what if we ended up with one of our roots in there? So let's say we wanted to determine the exact value of, we'll say, tangent of 60. So we're in the same triangle, right? So 60 degrees is in this triangle, so we probably don't need to draw it out again. So from the perspective of 60 now, remember your tangent ratio is opposite over adjacent. So from 60, your opposite is root 3, and your adjacent is 1. So our tangent ratio for 60 degrees is root 3 over 1, or just root 3. And that's our exact value there. So let's try it one more time. So I'm going to give you one to do for yourselves. So go ahead and determine the exact value of cosine of 45. So if you draw your special triangle here, this one is pretty boring. There's not a whole lot going on. So it's 45, 45, and then 1, 1, and root 2. So we have two 45-degree angles, but it doesn't matter which one you work with because the side lengths are also the same. So if we do cosine of 45, remember cosine is adjacent over hypotenuse. So regardless of which 45 you're working with, the adjacent for both of them is 1, and the hypotenuse is root 2. And so that is our cosine ratio for 45 degrees. And so this gives you a pretty good sense of how we're going to work with the special triangles. So we need to get a sense of how the angles and the side lengths work together. And that gets us the ability to kind of work through different situations depending on what we're trying to find. So, for example, if we were going a different direction now, let's say I told you that tangent theta is 1. So then what's theta? Well, tangent, remember, is opposite over adjacent. So if opposite over adjacent is 1, that's really going to be 1 over 1, right? We want to write it as a fraction. And so then we go back to our triangles and say, okay, well, if this is my opposite and this is my adjacent, then the only angle that has an opposite and an adjacent of 1 is 45 degrees. So the only way this works is if theta is 45. So see if you can do the same thing. So if I tell you that sine theta is root 3 over 2, go ahead and tell me what theta is. So root 3 over 2, if we're thinking in terms of our special triangles, the triangle with the root 3 and the 2 in it is our 30, 60, 90 triangle. So the 1 is here, the 2 is on the hypotenuse, the root 3 is there. And so now we've got to think, well, sine, remember, is opposite over hypotenuse, right? So in this case, I want my opposite to be root 3. And I want my hypotenuse to be 2. Well, that one's a given. The hypotenuse is automatically 2. But I want my opposite to be this root 3 here. And so the angle that has an opposite of root 3 and a hypotenuse of 2 is 60. So that tells me that theta is 60 degrees. We can also use this to calculate some exact values for lengths. So let's say we wanted to find the exact value of the length of the side of a triangle. So we'll have a triangle, looks something like this. And so this is 30, that's 20 meters, and this is x. So we're still doing trig, so we can kind of follow along with sort of the basic steps even from our grade 10 trig review. First thing we probably want to do is label our side lengths, and then probably pick a ratio, and plug in some numbers. So if we're labeling from the perspective of 30, x is our opposite, 20 is our hypotenuse. So from that, it looks like we're back on sine again. So sine theta is O over H. So we're going to plug in some numbers. So we take our sine ratio, and we get sine of theta, which is 30, so we know the angle, is our opposite, x over hypotenuse, 20. So right now, if this was grade 10 trig, we could absolutely just cross multiply and figure out what x is. And on this particular question, that would actually get us a decent answer. But in general, if we're doing exact values, we do need a slightly different process. So let's think in terms of our special triangles real quick. So this is the 30, 60, 90 triangle. I'm going to sketch it out again, just, for practice. So this is 30, 60, 90. 1 is across from the 30, 2 is the hypotenuse, and root 3 is down here. So you can't just look at this and say, oh, x is 1, done. Because that doesn't take into account the fact that this side is 20. So I'll teach you a really quick way to do this particular question once we're done, but I'll teach you first the way that will work for any example like this. So what we're going to do is we're going to use our special triangles to figure out the value of the trig ratio. So in this case, we've got sine 30 as part of our question. And so we're going to use our special triangle that we've already drawn out here to figure out what the value of sine 30 is. Thankfully, this one is going to be pretty clean because I chose a nice one for start. So if we look at our special triangle, sine of 30, right, is our opposite over our hypotenuse. And so that is 1 over 2. So in general, the value of sine of 30 is 1 over 2. Which we actually knew because we did this way back at the start of the lesson. So that was the first one we did, was the exact value of sine 30. And so we already figured out that it was this. And so coming back down to our question here, we're almost done. What we're going to do is we're going to take that thing we just found and we're going to plug it back into our trig equation here. So we're going to replace the trig ratio in the question. In this case, that's sine 30. And so we know what sine of 30 is. So this is where we left off before. We had sine of 30 equals x over 20. And so we're going to take this and we're going to replace it with 1/2. So we're left with 1 over 2 equals x over 20. And so this is just a proportion. And to solve this, we're just going to have to do a little bit of cross multiplying. So we multiply the diagonal things, right? So we're going to do x times 2, 1 times 20. So that gets me 2 times x equals 1 times 20. To solve that for x, I'm just going to divide both sides by 2. And so on the left, I've just got x. On the right, I've got 20 divided by 2, which is just 10. And so for my final answer, in this case, it's just a clean integer. The exact value of x is just 10 meters. But sometimes we're going to end up with roots as well, and we would just leave them as roots. In this case, we could have actually done this one a little bit faster just by coming back up here and say, okay, well, comparing our special triangles, my hypotenuse is 10 times bigger, right? So 20 versus 2. So this side versus that side. So if my hypotenuse is 10 times bigger, then my opposite side, which was 1, is also just going to be 10 times bigger. And so 1 times 10 would have just gotten me 10 there as well. That can work, but it's not a good habit to get into because it's not going to work for every situation. So your best bet really is to just do this cross multiplication stuff. So looking at another triangle and giving you a chance to try this on your own, you're going to figure out what x is using exact values. So we've got this triangle here. This side is going to be 75. This angle is going to be 40. And you want to figure out x. Now, granted, you could figure out this side down here and then do Pythagorean theorem, but please don't do that. So try to always do this in the most efficient way possible and as few steps as you can. So go ahead and pause here and try to figure out what x is on your own. Okay, so if I label my sides, 7's my adjacent, x is my hypotenuse, a and h means I'm working with cosine. So if I plug in what I know, well, my angle's 45 degrees, my adjacent is 7, and my hypotenuse is x. If we look at our special triangles, so I'm not going to copy it out again this time. I'm going to be a little bit lazy and I'm going to scroll up. And our 45-degree triangle, we're here. So the cosine value of 45, we actually already did again, and it's just 1 over root 2. So coming back down here, we know the cosine ratio of 45 is 1 over root 2. But then we're going to take this 1 over root 2, and we're just going to plug it in there. So we're left with 1 over root 2 equals 7 over x. We do some cross multiplying. 1 times x is just going to get me x, and 7 times root 2 is, well, 7 times root 2. We're not going to get into decimals. We're not going to do anything harder than that because we were asked for an exact value. We do need a unit, though, so it's 7 root 2 meters. Okay, so I'm going to wrap this up with just one quick word problem just to get you to practice a little bit more, and then that will be it for section 2.1. So here's our question. So we've got somebody who's standing between two buildings. She knows how tall the two buildings are. So one is 20 meters tall, the other is 30. And then we've got an angle of elevation from where she is standing to the top of each of the buildings. So one is 60 degrees and the other is 30 degrees. So just a quick refresher for you if you don't remember from Math 10, an angle of elevation is always an angle above a horizontal line. So elevation means elevated, means higher, and it has to be a horizontal line. So we want to know how far apart these two buildings are. So if you feel up to it, try to pause me here and see if you can do this whole thing yourself. Or if you're a little bit stuck, maybe just go through step by step with me and pause once you think you know what to do. So I'm going to start by visualizing, and then I'm going to set things up, and then I'm going to actually get myself an answer. So do as much as you can, pause where needed, and then watch what you need to do, and then try to keep going from wherever you're able to. So let's start by visualizing. So we're going to have, well, we've got the ground. It's a good place to start. We've got two buildings on the ground. So one building is taller and one building is shorter. So maybe, I don't know, something like this. Not too focused on specifics. We've got a person who is standing between the two buildings. And we've got angles from where that person is standing up to the top of each building. We're going to ignore the fact that the person has a height and assume that maybe she measured from the ground. And so we end up with something that looks like this. The angles aren't perfect. I'm not really too fussed about your drawings being amazing. This is just a good sort of baseline. We're told that one of the buildings is 20 meters tall and the other one is 30 meters tall. And we know what these two angles are. So our smaller angle to the top of the smaller building is 30 degrees and the angle to the top of the bigger building is 60. So this is everything we were given in the question. And the last thing to know is that we want to find this distance here. So if you haven't already tried to do that yourself, feel free to pause here and see if you can figure out what to do. If not, just keep watching. So I'm going to kind of break these triangles up into two separate triangles and work with them independently. So the triangle on the left looks something like this, where we know this is 60 and we know our opposite side over here is 30 meters, right? Because this distance, the height of this building over here, is the same as this distance there. And we want to find this distance on the bottom, which I'm just going to call x. So if we're looking at that, that's going to be a tangent ratio. So the tangent ratio specifically for 60 degrees is our opposite, 30, over our adjacent x. If we're thinking of our 30, 60, 90 triangle, which I'll scroll up to here to find, a little ways up. All right, so here's a good example over here. So the tangent ratio for 60, our opposite over our adjacent is going to be root 3 over 1. And, you know, it wouldn't be the worst idea just to draw it out here as well, so maybe I'll do that too, just for a little bit more practice. So this is 30 degrees, this is 60 degrees, and so this is 1, 2, and root 3. So our tangent ratio for 60 is going to be root 3 over 1, and that's going to equal 30 over x. So if we cross multiply those, we're going to end up with root 3 times x equals 30 times 1. 30 times 1 doesn't count for much, but we do need to move that root 3, so we're going to divide both sides by root 3. And we're left with x equals 30 over root 3. Now we're going to do the same thing for the other triangle, for the other building. So that triangle looks more like this, where this is 30 degrees. This is 60 now. And we know this building is 20 tall. And so I'm just going to call this distance y. So now we're going to be doing tangent of 30 instead of tangent of 60. And that's going to be my opposite, 20, over my adjacent y. So the tangent ratio for 30, if we come back up here, isn't going to be root 3 over 1. It's going to be 1 over root 3, because we've kind of switched around what's the opposite and what's the adjacent at this point. And so this is going to be 1 over root 3 equals 20 times y, or 20 over y. We cross multiply, and in this case, we end up with y is 20 times root 3. To get our total distance, so if we know the distance from where Kelly is standing to each of the buildings, x and y, to get the total distance, all we have to do is add those two things together. So our distance is 30 over root 3 plus 20 root 3. And that's all going to be in meters. I would honestly be totally fine if you left this here. This is where I kind of want you to leave this in this chapter, but we could go a little bit further with this. If we rationalized the one on the left and multiplied the top and the bottom by root 3, we'd end up with 30 root 3 over 3. And then we can simplify the 30 and the 3 to get 10. And so this becomes 10 root 3 plus 20 root 3, and we can add those together to get a final sort of fully simplified answer of 30 root 3 meters. But again, I do not expect you to do that at all, so please don't feel obligated to. You could also kind of go a different route and do common denominators here. So this would be 30 over root 3 plus 20 root 3 over 1. And so your common denominator for these two things would be root 3. So you'd multiply the top and bottom of the one on the right by root 3. So not rationalizing, just doing basic fraction stuff. And so we'd get 30 over root 3 plus, well, these two roots would cancel out. And so we'd have 20 times 3 in our numerator on that one, and then just root 3 on the bottom, which would be 30 over root 3 plus 60 over root 3, which if you put them together, is going to be 90 over root 3. And then you could rationalize that, and you'd end up kind of in the same space as over here. Again, none of that's necessary. I am totally happy with you to just leave your answer like that. I actually don't really want you to go through and do the rest of the stuff because it's just unnecessary work for what you're doing here. So try to be efficient. Don't do things you don't need to do. All right, so this wraps it up for section 2.1. There is one more video to kind of cover the first half of the unit. So that's the 2.2.2 video. And that one's really going to draw together everything we've done so far. So go ahead and watch that one. And then once you're done with that, you'll be able to move on to the second half of the chapter in 2.3 and 2.4.